my people? We are here with lesson 2.3, investigating specification. So let's start with our warm up here. So for our warm up, we have to do a little bit of, I would say, deepish thinking here. So we're going to look at this ancestor population, and we're going to make some guesses as to its descendant species several generations down the road. So we have an ancestor population that lives in a green forest, and we have a descendant species one who lives in Brown Hills, and descendant species two who lives in a green forest. So the question is, which population of frogs is likely to have more changes after many generations? The one that went from a green forest to the Brown Hills, that descendant species, species one, or the species two, descendant species two that continue to live in a green forest habitat? And then after you answer that question, you're going to explain your reasoning, your thinking here, and then we'll move on to part two. Ha! Just kidding. I want to make sure you guys are getting this. So, we should have definitely chosen descendant species one. The question was, which is more likely to see more changes? Well, the green frog, or the ancestor population, and the descendant species, they're sharing a kind of a common environment. So adaptive changes to that environment are less likely to occur because the green forest, or I'm sorry, the ancestor population frog here is already adapted to that environment. So we should choose the different environment. Certain adaptations in that environment may be different just based on the pressures from that environment. Okay, now we can go on to part two. So, in your last lesson, students, you were asked to choose an article. You either got to do Galapagos turtles, flightless ducks, or polar bears. So, depending on which one that you read, depends on which one of these pages from number two you need to go to. So, on page one, they have Galapagos turtles. If I click down here at the bottom, page two is the polar bears, and page three is the flightless duck. Now, you're just going to reread a couple paragraphs here from those articles, and then there are questions about those articles. And all the questions are pretty much the same. How did the original population that became two descendant species first become separated? One of the populations had structures that changed over time, describe the changes that happened and why they happened. And then we have one more. Why did the other population in the article stay mostly the same? Or there's our vocabulary word, stable. So go ahead and do your rereading, answer those three questions, and then we'll move on to part three. Okay, so we are going to be playing with australopes today. Now, for this one, we aren't going to divide up into pairs or anything like that. We're just going to be focusing on this one change here. And I think it'll just be a little bit easier for us to do. The bottom line here, though, is we're going to see if we can see some changes over time with australopes, with them having longer necks. And we're going to do that by manipulating the length of the thorn palms that they eat, and we're going to do that by manipulating the frequency in which they occur. So don't worry about pair B. We're going to focus on the A side today. So make a prediction here. And actually, look, before we go any further, let's take a look at this. So this is what our sim is going to look like. So the idea here is we want to. These are the australopes. These are the thorn palms, and we're going to try to make these taller over time and let these critters run around here and reproduce, and we're going to see if they eventually adapt to that change in the environment. So we're going to make a prediction first before we get to play in the sim. Do you think that the population in the environment will remain remain stable or change over time. And this is just a prediction, but we should already, at this point in the unit, be thinking, yeah, the population will probably change. Um, and then if you think it will change, what do you think will happen with the Australope population environment? I kind of already spoiled that one for you. So let's go do the sim now. So, first things first, let's click on our sim. Let's get that up and loaded. And use the menu in the upper left-hand corner to open the from one species to two mode. No, I'm not using an iPad. Okay, here we go. One of these days. There it goes. Okay, so in the upper left-hand corner, from one species to two, that's what we want. Okay. Now I do want to hit rebuild because I was playing in this earlier. If you were playing in it earlier, you might want to do that as well. Let's see. So we're going to take our thorn palm icon. We're going to click that. We're going to change the most common thorn palm height to 4. Change the variation to medium. Okay, let's do that. So here's our little thorn palm icon right here. We're going to change it to, notice it was at 2. We're going to put it at 4. And the variation we're going to put to medium. And before we start, let's look at our little critters here. So notice their average neck length is 2. We don't see any variation. It's turned to none. But our mutations is turned on, so that's great. And if we click here, it says neck length affects whether an australope can eat thorn palms of certain heights. So we can see already with this information that this is having a longer neck will be a little bit more beneficial. Now, before we do anything else, I do want to zoom in a little bit here and just show you. So these are our little critters running around. These are our australopes. And these other little guys, those are our thorn palms. And let's see, here's its height, it's alive. Let's click on this. This one's looking for food, its neck length is 2. The other part of the sim we can investigate is jaw strength by putting more thorns on them, but like I said earlier, we're just going to focus on neck length because that gets the point across. So, the most common, blah, 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 press run and observe the changes. Okay, so let's do that. We're going to go run, and yes, look at them all go. I couldn't find all my buttons. You can zoom in, and you can just, oops, here, let's make sure it's going. And you can watch them go around. Oh, yeah, look at, they just had a baby. Let's turn this up. You can turn the speed up. It says we want to get to 50 generations, but hold on. What are these little critters running around with the red here? What does that mean? Look, this one was born with a mutant trait. 2 of them, in fact. Neck length is longer, jaw strength is weaker. Look at this one's already got a neck length of 3. Uh-oh, this one was born with a shorter neck length. Uh-oh. I wonder if that trait's going to die off soon. Let's find out. Remember, we want to get to 50 generations. You can watch them all go like this. You can zoom in. Kind of scroll around. Sometimes it's kind of fun just to find one. This one's just wandering. Oh, he's starving. So I got that short little neck. Died from starvation. looking good for those short neck critters. Born with a mutant trait. Look at this fellow. This person. This creature here. This creature has a neck length of 5 already. Oh, even with a neck length of 5, that one still died of starvation eventually. How sad. Oh, wow. Jaw strength's huge, but neck length not so much. He's starving. Wow, a lot of mine keep dying. Neck length of 6. Okay, so I believe we wanted to go for 50 generations. Oh, and we're going to press analyze. Where is my... Oh, there's my analyze. Okay, so here we can see this was our baseline, where all of our creatures, all of these australopes, had a neck length of 2. Over time, we could see how that changed, where the average was between 6 and 7, and probably closer to 7 uh, in overall length. So we can see over time how, and we even saw it in the sim, where there were shorter necked creatures that didn't make it. They died and weren't able to reproduce, but the ones that were able to get the most food were able to reproduce. And over time, we can see those changes can add up substantially. So, friends, go ahead and take a screenshot. That's your control show button on your Chromebook and upload that image. Um, and since we didn't do draw strength, we don't need to do that one. And we don't even, let's not even, we don't need to really worry about answering those questions now. Just make sure you get the sim done. And let's go to part 4. So for part 4, there's a modeling tool here. And you're going to kind of model the same concepts that you saw in the sim. So the first thing I think we should do is click on the bottom of these cards and indicate whether it's a common ancestor or descendant species. So we can see the branch. It branches off here, so this is our common ancestor population. Descendant species, descendant species. Now, basically our instructions is to show how a common ancestor population can become 2 different descendant species when it is separated into 2 different environments. So the first thing we're going to do is we're going to choose our 2 environments. We don't know what environment the common ancestor came from, but it doesn't matter. So let's pick, you can pick water, swamp, or land. I'm going to pick water, and I'm going to pick land. Now there's information here about adaptive structures. That would be structures that are better suited for different environments. So for water, we can see we've got long tails, small back limbs, and nostrils on the top of the skull. And then for our adaptive structures on land, we have short tails, large back legs, or back limbs, and nostrils in the front of the skull. So now we just need to indicate those things. So we're going to click on our little fossil here. And for this one, since I'm doing water here, I'm going to want to put the nostril on the top. I think he needs a long tail, yes, and tiny little front legs, or back legs, sorry. Then for here, we're going to want, it says our nostrils in the front. We're going to go with a short tail, and we're going to go with some big buff legs. And there we go. So now we've modeled basically how one species can start in one way, but with environmental pressures over several generations, they can adapt or, adapt different changes. All right, friends, push that hand in button and answer this question right here. Explain how your model helps answer the investigation question. then push the hand in button down here, and then you are done. Thank you for watching. Don't forget to like, share, comment, subscribe, and don't forget, be nice.